Find the average value of the function f of x equals 2 cosine x over that interval. So just use the formula, no? Average value, just write average value would be one over, we just go 1 over b minus a, which is what? Pi by 2, that's b, no? Pi by 2 minus a negative pi by 2. A and B, you see, let me see, A and B. Then we have the integral from A to B, negative pi by 2 to pi by 2 of this 2 cosine x dx. All right, so yeah, there's that. And so we're gonna add here for this one out here. No, some of these colors, that's why I stick to some colors that are good, that stand out on them. All right, so we're gonna add, so it's gonna be pi by 2 plus pi by 2, what is it? Pi, just pi. So pi, and we're gonna integrate that. So what is the integral of that thing? Where's the integral? We could have factored out that, well, there's 2, then it's gonna be, what's the integral? Cosine x? Whatever sine is cosine. So it just be sine x. And evaluate it from negative pi by 2 to pi by 2. Okay, so it's just algebra again, one more time. So this is the whole thing together. I'll just plug in pi by 2, and then put the pi next to it. 2 pi sine pi by 2 minus, okay, because, and then minus 2 pi sine of negative pi by 2. This quantity. And it goes back to trig. If you are good with trig, sine pi by 2, what is it? 1. So it's going to be 2 pi. This should be in sine of negative pi by 2. Okay, we're going to negative pi by 2. That would be what? Negative 1. So positive 2 pi.
1 over pi.
Say what again?
1 over pi.
1 over pi. Where at? How?
We got the pi by 2 plus pi by 2. So
Oh, it's 4. I was going with. Yeah, because it'll be pi. Hold on, pi by 2 plus pi by 2. Basic math, 1 and 1. Well, wouldn't that be 2 pi over common denominator 2? And you just, it would be 1 over.
yeah.
And over here, then we got this wrong. Good, thank you. So it would be, where can I fix it? Over here? So 2 over pi, no? 2 over pi, you said? Sine? And then here, minus, 2 over pi? Yes. Okay, so here sine pi by 2 is what? It's 1, we said, so it'll be 2 over pi, and then this one over here it'll be negative 1 plus, and then plus 2 over pi, and that'll be 4 over pi. Yeah. And what it means is that the average value of the function 2 cosine x and this is the graph of 2 cosine x from negative pi by 2 from negative pi by 2 to positive pi by 2. This area, let's see, well, the average height of it, what would be the height that would give you what we said, no, like a rectangle out of it, no, make a rectangle out of it that would fit that area right there, and it would be that much, which is 4 over pi. This height is 4 over pi. Yes, good. All right. Yeah, I don't know. Sometimes making mistakes is good. It is to learn it better and to really understand what's going on. Connecting position, velocity, acceleration of functions using integrals. Like I just said, for sure, this is tested on the AP test. For sure, it's getting into the meat of it, the conceptual. It was my mistake on that one, man. I was like on the simple algebra, and I keep talking. All right, let's go. Connecting position, velocity, acceleration of functions using integrals. We've done position, velocity, and acceleration before we did any integrals in chapter 5, in chapter 4, and now we're gonna do it with integrals. Okay, so we gotta really understand what these expressions mean. A displacement of the particle, in other words, net distance traveled by the particle over the interval from A to B. Yeah. This is talking about particles, connected position, velocity, and acceleration of functions, and I'm right here talking particularly about particles. It's basically saying that you can do anything. If it started at A and it did whatever it did, like it went backwards, went forwards, it did this, we're like, okay, do whatever you want to do. All we care is where do you end up at, and then find the difference between A and B. That's the displacement from A to B. Yeah, that's it. And for me, that I'm right now, I'm looking at the stock market. I started with 10,000, and at last year, at this time, and then I went down to some 5,000 and whatever. It went up to 50,000. I did nothing. It went this. So it did whatever it did, and at the end, I ended up with 11,000. So the net is I made 1,000, and it's basically the same thing here. Okay, you start with something, and then you ended up somewhere, and then just what's the difference between them, I guess. All right, mathematical meaning. That's what it means. It's the area under the curve from A to B, V of t dt. And yeah, and to look at this from A to B, V of t dt is exactly what I just said in a more formula, in a area model way, where we're saying that this is t and this is V of t, and they started say at A is 0 and say B is whatever B is, and then you made money, you lost money, made money, lost money, and ended up right there, whatever. And it seems like you would have made money just the way it is, that you were making money. You started with that amount, you lost that, you made that, so it looks like you're up because you still add up to way bigger than this, and at the end you ended up positive in terms of area looking at it. And it's, yeah. So final position of a particle. How do we do that final position of a particle? It goes back to the connection of the, Yeah, with the fundamental theorem of algebra that we said, no? That we said that, don't write this down, I'm just gonna, and then go to it. A to B is equal, V of t, dt, is equal to S of t, d minus S of B minus S of A. So we're going again that this is a velocity here, this is a velocity, this is a position, and so we want to find what the final position of a particle is. Well, this is the final position of the particle, and we started there. So we can just subtract it. So it's, and then put it over here. So it is S of B will equal to S of A plus A to B V of t dt, and that's what we did already. Where at time equal to whatever time we were at this position, and then we ended up there somewhere. That's what we've done before. All right, that should make sense, and there it is. Average velocity of a particle on an interval from A to B. We just did it. We just is you either divide by the interval, or you can multiply it by 1 over that. No? So there, we just did this. And now here, total distance traveled by the particle over an interval AB. That is basically covering it all. Is that you could have gone, say here you're in Fresno, and say going to Sacramento is positive. So you went up to Sacramento, drove back down to Bakersfield, drove back to Fresno. Your net displacement is 0, but your total distance is, well, you're gonna have to add up all that you went there, and then also add up how much you went down there, and add up how much you went there. This is a net, a positive. That's also a positive. That's a positive. This is adding up all the distance you traveled, no? It's an absolute of it. So it's kind of this physics related. So now, what is that though? Total distance traveled is an absolute. It has to be some kind of absolute of it, no? Yeah. The absolute of the velocity inside of the integral. And it makes sense. Why does it make sense? It's because like if like we were talking about area under the curve, and this is t and v of t, and you went up positive to Sacramento, back to Bakersfield, and back like that. Well, this is already counted as a positive distance. This is you went back, but still we want an absolute of it that will make it positive. Whatever that is, make it positive. Count it. Yep, you have to count it. All right, good. Number 1, let's go from 1 on it. It should be pretty straightforward here. We already, just doing an example of it. A particle moves along the x-axis, so that at time t, its position is given by s of t, velocity is given by v of t. Okay, match the following integral expressions to their verbal statements. A, the integral from 1 to 8 of the absolute value of v of t dt. What matches with that one? Don't say anything. Let's go. Where's my thing here? Copy it down, and then I'm going to ask one of you guys match it up. I don't even have it. Like, this is such a small class. I didn't even print it out. How can I not know names though? 5 people? Oh man, I have really bad memory. But I think I'll go with. Why you always look scared, Anthony? You always look scared, like when you're like looking at him like, Jacob, A.
Absolute, so say.
So which one? 1, 2, 3, 4? Which
Other
one?
distance.
A goes with what?
3.
Oh, wait, I did it backwards. Where, okay, I had it before, I had it like that when I did my, but yes, this is 3. Let's go. This 3. No, this, yeah, this 3, no? Crystal, which one, what's B? I should have changed, which one's B? Huh? That's 4, huh? What am I doing? This is 4. Sean, let me see if you can get that one. I tricked it. It's a trick question, man. I got this one. What is it?
I think it's number 1.
Man, you're good.
Thanks.
D. All right, whatever. Like, didn't work out as well as we. All right, let's go. Let's move. Let's do some problems then dealing with this. A particle's velocity is given by v of t. Where t is measured in seconds, v is measured in feet per second, and s of t represents the particle's position. What is the net change? What is the net change in distance over the first 5 seconds? Pretty straightforward here. What's the setup, Jacob? What's the setup? Huh? What's the setup?
It should be ST.
What is the change in distance?
It's S applied. It's S applied into like integral of ET. Minus by ST.
What is it? What is it? What do you think over here? Susan, is it like that? Just the integral, no? It's just the integral under it. We're not asking for a position where is it at 5. It's just the change of it. It's just the integral from what? Of v of t? Yeah. 2t minus 8. That's all. Integrate it and plug it in. That's all. That'll get you the area. And yes, and so let's see. Okay, so that's what it is. We're going to integrate that, and that's going to be it. So the net change, I guess, in the little triangle like that, is net change in the first 5 seconds would be. Integrate that. What is it then? That's going to be gone. That's 25. And is that negative 15? Is it negative 15?
I have a question.
What?
You know how sometimes there's a plus C after? How do you know if it's...
That's a good question. I said anything about it. Yes. There's a big difference here when we say definite integral. This is definite and indefinite integral. Indefinite. So a definite integral, you just want to find the area under a curve from A to B, and you have bounds. When you have, that's a definite. In the indefinite integral, just find the antiderivative of something. So what's the integral of x squared? Just give this one or dx and whatever it is. But you just finding the antiderivative kind of thing here.
So there's no bounds on that one?
Yeah, no bounds. Just like say, what's the integral of x squared dx? Well, that's gonna be x cubed over 3 plus c. Where this from the definite integral, you have numbers and bounds, and you're gonna get a number here. Where here you're getting a formula, the antiderivative. That's yeah. All right, so negative 15 feet. B. That's the one you're talking about, Jacob. Where are you at position 3? Well, at t equal to 3. Where are you at t equal to 3? What's your position on the number line? Is this a number line?
I'm going to answer.
Whatever?
I'm going to answer.
What?
Okay, I'm not going to answer.
You want us to already give the answer? That's the one you were applying to. You're applying it to this one. It's not that one. That's this one where you do that S of the one S of B equals S of A plus integral. Where 0 would be A, and then B is 3, so we were looking for S of 3. Integrated. That's gonna be 0. That's gonna be what? 9 minus 24. What? Is it? Still, is that negative 3? So it's negative 13? Because that thing's gonna cancel out. That thing is by itself. So yeah, in this one has no. The net change here is negative 15, and this one has feet. This one doesn't have feet. All it's saying it's at position out on the number line. It is at 13, negative 13. Okay, if this is 0, then you're at station negative 13. It's not talking about how much you move. That's where you're at. Yes, kind of thing. Next, C. What's the total distance traveled? Which is that one? Anybody? What are we doing there? Yeah, because it's talking about total distance. You went to I told you to go to Bakersfield. You went to Sacramento. You wasted all that gas, and then you went back down to Bakersfield. I'm gonna charge you for the total. You see, I'm gonna charge you for, or no, what is, or I'm not paying you for that extra gas you wasted. That's on you. But you wasted all that money going, yeah, the total. Now you would have said, well, I'm just gonna pay you for that displacement. I'll pay you that you should have gone from Fresno to Bakersfield is 200 miles, but you went 500. So displacement is just the displacement is different. So total distance traveled by a particle during the first 5 seconds. Yeah, it's the integral from 0 to 5 of the absolute value of that 2t minus 8 dt. All right, here's a question. Here's a question for you guys. Do we need to find any critical points? Because if we're talking about velocity, say I went to Sacramento, and this is t and this is velocity, and I went to Sacramento. I should have gone down south, negative, or going north is positive, say, and I went like that, and then I went like that. So there might be some critical point here, and so do you really need to find here and integrate from here to here, wherever that critical point is, 0 to say, what is that, 5 seconds? 0 to 3, it went like that, and then from 3 to 5, it went like that. So do I necessarily need to find this and then integrate from here to here and from here to here? Or could I just see in a calculator? Yeah, if you don't have a calculator, you can actually just plug it into a calculator. A calculator would actually solve it. If you say from 0 to 5 of 2t minus 8 absolute value of this dt, the calculator will actually compute this and then get this and do the absolute value of this. This is already positive. So we would do this and then get you the correct answer. But so for here, we just want to know, is there any critical point in between 0 to 5? Is there a critical point? Is there a time where it changes direction? So we got to do that first. So let's do that. So this is the velocity, and does 2t minus 8, which is velocity, does it change direction at any time in that interval from 0 to 5? And it did, no? Yes. So you would probably want to integrate from 0 to 4. Take the absolute value of whatever that is. Maybe it's already positive, but don't take a chance. You take the absolute value of that, and then do an absolute value of from 4 to 5, an absolute value of that, just to not take a chance on it. Let's see. Now, how do you integrate these absolute value ones then? Basically, what? What do we do when you have absolute value like that? Okay, I guess you could just still continue on having it inside. You could still integrate this quantity like you integrate anything. Okay, t squared over, okay, t squared minus 8t, but still have it as an absolute integrated from 0 to 4. Okay, plus you're going to integrate that, and it's going to be absolute value from 4 to 5. Let's see here. So for this one, when you plug it in, because you're evaluating here, plug it in, and then we're plugging it in here. We already know plugging 0 to anything here. This whole thing is 0 for this part I'm doing. And then we go over here, and we're gonna oh, look at that, 5 and 4. See, this right here is gonna work out to something else right here, because we're plugging it in. It's just all that 5 into this, and then subtract it when you plug in 4 and 4 here. and it's all the math going on here. This one turns out to be absolute value of negative 16 plus that. And absolute value of negative 16 is 16. Absolute value of 1 is 1. 16 plus 1 is 17. So it would have been, could we have, is this too much? Now I'm asking my own question. Could we have done it just going an absolute value of the whole thing from 0 to 5? Let me do it real quick here. You guys, let me do it. Let's do that. From 0 to 5, could we have just gone like this then? And do the absolute value of what? 2t minus 8 dt? Could we have gotten the same answer? Why not? Probably not. So it's going to be what? Integrate the inside. It'll be what? It is what we had, t squared minus 8t. And then integrate it from 0 to 5. And then plug it in. What are we getting? A 25? Because that thing is going to be 0. 25 minus what? No, 25 minus what? What would have? Negative 15? It would have been wrong. Make sense there on this one, Crystal? Yeah, it's good. So yeah, you have to find that when you do that. But if you have a calculator, this is a calculator one, you could just, you could do that, and then the calculator will do it. I don't know. You guys got your calculators? What do you just figure it out if it does or doesn't? All right. Let's move on to number 3 so we can finish. I think a calculator will understand that you need to be cutting it, and doing all that. Three, for t greater than or equal to 0, less than or equal to 6. Particles moving along the x-axis. The particle's position x of t is not explicitly given. The velocity of the particle is given by that. The acceleration of the particle is given by that. And x of 0 is equal to 2. Let's go that one we did in chapter 6. The one was, let's see. Find the average velocity of the particle for the time period from 0 to 6. Good question. I like that one. Who needs the calculator? If you is this a calculator active? I think this you need a calculator to be doing this. Okay. Do you? Let me see. Find out from 0 to 6. Yeah, you need a calculator. How the heck are you gonna plug it in? Integrate. Yeah. We need a calculator. You guys, let me get your calculators. Calculator. Get your calculator. Which are you? All right, what would be the setup? Okay, average velocity, easy. We said it's easy. 1 over what? Come on. 1/6. Yeah. I don't know, EV, average velocity, I don't know. And from 0 to 6, here's the problem. The problem is what goes here? dx. What goes here? The dx? No, dt. And this is what you really need to, we really do need to understand. What goes in there? Does velocity go in there, or does acceleration go in there? Acceleration. Yeah. Because the area under the acceleration graph will be velocity. And then that's how we're going to get the average velocity. Let's let's plug it in. Go ahead and plug in. This is going to be A of t. It's going to be 1/2 e to the t to the cos e. We're going to on Monday we're going to practice how to use the calculator more, even more, like the whole time. Monday or something. I don't know. Something. So we're going to put that in there. Cos. All right, let's do that in the calculator. Let's go. We got that already. Answer. One over six times, right? Delete times integral shift plus integral 0 to 6. 1/2. I'm gonna put 0.5 for that. 0.5 e. I'm gonna just use x for t. Everything be x's. X over 4 cosine. No. E. This is up. What the heck is this? E again? Up button. Oh no, E, and then do the T of X. I mean X don't mix them up over 4. Please go. No. What you guys get?
I got 1.15.
I got nothing. Oh, I got this wrong. I got negative 0.6. I don't even know how to use the calculator. Are you guys using rating? What are we supposed to do? It's time. Why am I getting this weird number? I'm getting negative 0.6. No! We used the wrong one. No, we're not supposed to use acceleration. Let's go back to we need to go back to chapter 8 to section 8.1. Let's go back. This is bad. It's supposed to be velocity. Let's go back to the definition. Exit. Let's go to the definition. 8.1. You weren't here for for this lesson. Let's go to the definition. I think I need to review this myself. 3. Let's go back to the definition. Everybody, look. What is the definition? Average value of a function on an interval. Average value is the average height of the function f will equal to the area under the curve divided by the width of the integral. Average value of a continuous function f over interval AB. So now, here's the question. F, where's F is what? See, we go back to, if we don't define these things, then we can just say, oh, is that position? Is F position? Most of the time, F would be position. Because what? F prime of X is what? F prime of X is the derivative. No? Yes or no? So, F here, and this is a good thing that just happened, so we can all really understand that unless this, we really know what this is, we're lost. We see, so what does F represent? F represents that. So if this is velocity, then the average velocity, this is velocity, the average height of the velocity, of the velocity graph, okay, F is the velocity. And so if the graph goes like this, or whatever it does, and you want to do it from here to here, the average height is this, but it deals with the velocity. So let's go. Let's go continue on. So we have to understand that it's dealing with it within itself, and it's just finding the average height of it. Let's go back to it. Let's go back to the lesson over here. Let's do it again. So it's that one. Hopefully, this was a good lesson and we get the correct answer. Did you guys get that number? That answer?
I got 1.49.
I would be lying if I said that was a whole. This was on purpose. That's those we got, no? 1.949. Make sure you guys round. If we already messed it up, and if you even know how to do it, and you mess it up with this 9, and you put a if you don't get exactly this number, they'll give you 0 on the AP. That's how they are. So you better know how to round correctly. You get that exact number all the way to 3 decimal places. All right, let's go to B. Looking back what we had done in the other one, we would have found the average acceleration the way we done it, no? Does that make sense? Yeah, we would have. So total distance. Oh, we're talking about that absolute. Would it do it? Would it do it? The calculator would it do it? Just go from what? What do we? Total distance is what? Absolute value, no? So find the total distance traveled. Now, what are we gonna put in for that part? The integral function. So we are gonna go from 0 to 6. Annotate. Total distance. Integral from 0 to 6. What goes in there? Find the total distance traveled. No, this one has to be acceleration. This has to be the area under the acceleration is velocity. Oh, find the total distance. Yeah, it's velocity. Yeah. So it is velocity. What you get? Because we get it, no? That we go back. What area under here? If this is velocity, the area under it is distance. Yeah. All right. So what would you do? 12.5. All right, let's go to C. Let's go to C. This is two parts. We want to know. Look, this is getting into, and that's what we haven't been doing a lot of using our graphing calculators, but we want to know when does velocity change direction. We have the velocity equation here. What we could do, let's go, get your calculators. Let's do it this way. I don't know if you're gonna remember. Save it. Let's go. Get your calculators. Let's save the calculator. Do we need to save it? No, we don't. I need to learn how to use this calculator too, though. See, that's the problem. We can either graph it. Let's go ahead and graph it. And we're just gonna go and see where does it and then figure out where does it cross the x-axis, where does it change direction. So let's go ahead and graph it. Let's go to use our graphers. Graph. Let's do it this way. With your graph. Graph. Enter. And I don't even know how to tab it. To F of, okay, so I'm somewhere. Man, what is this? Get out of here. Okay, okay, go. Let's go. F01. I'm not F01. Put in that V of t. 2 times sine. 2 times sine. Parentheses. 2 times sine. Parentheses. E to the power of. Enter. I'm gonna continue on with just x's, and this is x, and just keep it the same. If you want to keep it all t, just plus 1. Enter, please work. There it is. I'm getting a graph. Look between, it says once. Look, zoom in, or you could find the zeros. You can go to menu on that one. And go to actions, or no, go to 6. Is it analyze graph? Find the 0. So go to analyze graph 1, and then it's gonna give you from where to start to where, and you already can identify it. It's gonna be the first one. Enter it. Enter. Menu, analyze graph. zeros, enter, move it over. Stupid thing, I don't know how to use this. How do you do this? Analyze graph. Where are the zeros? Intersection, where are the zeros? Then you go from there. Do you hold it and move it over? Hold it and move it over. How do you do it? You guys, you already got it? You know how to do it? You know how to,
I did it.
you did it. Like you have to hold it and move it over. It gets an area,
Yeah.
a shaded area, and then it gets it.
The 0? Yeah.
Yeah, what's the word?
I got 5.195.
Okay, so you're gonna show us, you're gonna teach us how to do that, because I don't know. So you're gonna get that number. Once you get that number, then you can just go ahead and do the position of the particle at 5.196, and then just do x of that, which is gonna give you where it's at. And they're giving you that at time equal to 0 to 2, from 0 to 2, 0 to 2, and then you're gonna go to that 5.196 of the velocity function. And it's going to be all calculator work. Just put all this in a calculator. Put this in a calculator and it should give you the answer. That should be good right here.